Okay, so problem 29 is going to be the first one that I've not actually previously done. You can see right here I've got to actually put the answer in. It doesn't just tell me at the bottom like it has done the others, because I've previously done them. So yeah, so it's going to be slightly different. I won't know the answer till I put it in and get it right. But yeah, let's take a look and do it. So we're going to consider integer combinations of the form a to the power b. We have to work them all out for a in this range and b in this range. List them in numerical order, remove repeats, and then count how many distinct terms we have in that sequence. So hopefully that makes sense, but seems pretty simple, so let's get into it. Whoops, just realised you can't actually see what I'm doing. Okay, so what we're going to do, we're going to define a. So a is actually a is a loop, so we're going to say for a in range 2 to 100. And just because I forget every single time I do this, I'm going to check which side is inclusive. So I'm just going to call this. I think it's number 29. Yeah, it is. And just see what this prints. Oops. Gotta remember to call main. So it doesn't include 100, but it includes 2 if I remember right. Yep. So we're gonna have to go to 101 right here. This will then include 100. So we need to do for A in this range and then for B in this range, the same range. So 2 to 101. Now we want to say number equals, and it's of the form a to the power b, and then we need to put these all in a list in numerical order and remove repeats and then count them. So basically we need a list of numbers. It's going to be empty, and then we're going to say, now I'm not sure which way will be faster, and we will actually time this because this is going to be quite a quick one, so we may as well do the testing. So we're going to import time. The ways we could do this, we could either import every single number, append every single number to this list, and then afterwards strip out all the duplicates somehow, or we could do some sort of test as we add numbers to see is the number already in there, and if so, don't do it again. My guess is it will be quicker to just add them all in and strip them all out at the end. So, and that one seems the easiest. So we're going to do that one first. I will test out the other way towards the end if you're interested. So append the number. Then once we're done with our loop, we're going to say, I wonder if there's an easy way to strip duplicates from the list. Just having a quick Google of this, won't be long. Okay, so it seems like when you remove duplicates, you basically do something like this. So you say like for I in list of numbers. So we're going to have a new list. This can be empty, and you go over each one and say if I not in new list dot append I. So it seems like we're basically going to be doing the same thing anyway, and just creating a new list based on whether or not the number's already in there. So it's probably quicker to just do this up here, but we'll just do it this way and see what happens. Almost certainly it will be quicker when I change it, but may as well do it since it's already done like this. So we're just going to do start time equal to time.time. And once main's ran, we're going to say print time taken was seconds. Dot format. Time minus the start time. So the last thing to do up here is we're going to have a full list. So here we're going to have a list of all unique numbers. Now we need to order these. So to order a list, I'm pretty sure you can just call like list, oh no, it's new list now, so new list dot sort. Pretty sure that does it. I can't remember if it does it in place or not, but we'll find out. What I'll do here is I'll print new list. I think this is how you slice it. So let's just try this. Let's just run this, see what happens. Yeah, so print out the first 10 terms here, and they look pretty ordered to me. But you would expect that because it's going to be doing all the 2's first. So we're going to need like the first, let's say 110 terms. This will give us a couple that wouldn't be ordered if this wasn't the case, but they are actually ordered. Like you see here, we've got the 9, which is like 3 squared. It's in the right place. So yeah, sort has worked and done it in place by the looks of it. We could just check this by, if we print list of numbers of 210. Then the second one I would expect is going to be not sorted. So yeah, you see we've got some absolutely huge numbers here. This is 2 to the power 100 by the looks of it. Before we switch over to 3 squared, so yeah, this does it in place, pretty happy with that. So what did it want us to do? It wanted us to remove repeats, which we have done, and then how many distinct terms are in the sequence generated. So we need to now count distinct terms. So to do that, that's quite easy, just the length of it. So we just want to print len of new list, and then that there should be done. The sorting then wasn't actually necessary. We just needed to replace get rid of repeats. So this actually is completely unnecessary. But let's just run. So this takes 0.47 seconds. Now if I get rid of this sort, I wonder how much quicker this is. Okay, so it's slower. I'm guessing we're going to have to call this many times to see any sort of difference. Let's just say for I in 10, range 10. We're going to call main, and then this will just mean that we've called it 10 times so we can time it. I'll keep the print in there to slow it down. So it took 4.8 seconds. Now if we get rid of the, put the sort back in. So still 4.8, slightly faster with the sort still. That's interesting, I'm not sure why that is. I don't know if it's like, obviously we're not doing this too accurately since I have like background processes running. You should actually run this in the time it module, which I haven't actually used so far in this tutorial, like this series, but yeah, look it up if you're interested in doing more timing sort of stuff. It's a way more accurate way of timing computation and stuff to find out which functions are faster. But yeah, basically this should be our answer here, 9183. So let's go and see if it is. I'm just going to refresh this, we'll get a new capture code. So 9183, confirmation code 656T7. There we go, we got that one right. So yeah, pretty easy one. Only took so long because I was trying to. Oh, actually, let's. I actually forgot to do that. Let's go back and shot this stuff inside here. So basically what I want to say is this bit right here needs to be here, and then we can kind of just get rid of this and call this that, and get rid of this. So that should work, and it should be a bit faster. Oops, list of numbers. Okay, what have I deleted that I shouldn't have? I think it's I need this to be number. The number not in. There we go. And I need to not append I need to append number. So 4.8 and 4.8, so still not gaining any time actually. Quite surprised that the sort hasn't changed anything. But yeah, there you go, that's how it's done. Pretty short code, pretty simple stuff. Obviously you can take some of these lines out, like the start time and this gap down here. Don't have to be calling it 10 times. Yeah, there we go, happy with that. So yeah, thanks for watching, and I'll see you in the next video.